Good morning, students. In today's class, we'll discuss how to make an mathematical expression of given signal. In the previous classes, we have studied the basic introduction to signals and systems, and we have discussed various types of signals also, basic elementary signals such as uh, uh, unit step, then unit ramp, and unit impulse signal. And we also express these signals in mathematical form, and we also stated why they are called as unit step, why they are called as unit ramp, and why unit impulse. Now we'll take various examples and we'll illustrate how these signals, basic elementary signals, are useful in describing the mathematical expression of such given signal. So for example, suppose x of t is given to us and it is something like this. Please understand, my handwriting is not good. My drawing is not good. So I am interested in defining the mathematical expression for this signal. So now you observe this signal we can constitute by making use of u of t signal. Okay. So how the mathematical expression of this signal can be derived? So let us discuss in detail. So I will redraw this signal once again. This is a signal given to us. Let's say this is 1, this is 0, this is let's say 2, this amplitude is let's say 1, and this is 2. And we want to find the mathematical expression of this signal. Now if you understand, if you know very well, u of t signal is given by the expression like this. So my u of t signal is simply its amplitude is 1, and I already defined that u of t is equal to 1 for t greater than or is equal to 0, and it is 0 for t less than 0. So we have stated, we have defined this signal in our previous class. Now you observe this signal will exist only up to this point, that is t is equal to 1. At t is equal to 1, what is happening? The amplitude of this signal, that is u of t, will be increasing to 2. So what am I doing? I am adding unit step at this point. So if I add to this signal, a delayed version of u of t signal. So if at t is equal to 1, if I take the projection of this here, then at t is equal to 1, I have one more unit step like this, and I can define this signal as u of t minus 1 because it is delayed by one sample unit. I can rewrite this as u of t minus 1. Now if I add u of t and u of t minus 1, I will get a signal something like this. I will get a signal something like this. Just check whether I am correct or wrong. So from t is equals to 0, the signal will be starting. Its amplitude is 1 here. At t is equal to 1, when another unit step signal comes, a delayed unit step signal comes at t is equal to 1. What will happen? This signal and this signal get added, and its amplitude will become equal to 2. So at t is equal to 1, my signal will become like this. But now what I want is, I want this signal to get terminated at this point, that is t is equal to 2. So what I need to do? I need to bring down this amplitude, which is 2 at this point, that is at t is equal to 2. I need to bring down this amplitude to 0. So what am I need to do? So till this point, my signal, this signal x of t will be something u of t plus u of t minus 1 till this point, that is t is equal to 2. Now at t is equal to 2, I need to add, actually I need to subtract. I need to subtract. Which signal I need to subtract? At t is equal to 2, I need to add one more unit step. At t is equal to 2, I need to add one more unit step, but its amplitude will be equal to 2, and instead of adding, I need to subtract it. I need to subtract it. So this signal is 2 of u, amplitude 2. From this I am subtracting this. So from this I will get whatever the required signal. So, and therefore my x of t signal, which is this, can be expressed mathematically by this mathematical equation. Thus making use of unit step signal, I can define this signal. Let's take one more example. Suppose I am interested in finding the mathematical expression of a signal which is something like this. Let's say my signal is starting at -6, and here it is -4. Let's say this is, let's say, 0. Then here, do not take it with the scale, I am drawing it approximately, and let's say this is 12. Okay, I am not drawing with the scale, so please consider this. And my signal shape will be something like this. So from this 6, it will be this ramp like signal. So at 4, it is constant, and it remains constant till this point, that is till 10, and that at 10 its amplitude is again, there is one ramp like this. So I want to find out the expression for this signal x of t. So how one can find the expression? So this is my signal given to me, and I am interested in finding the mathematical expression for this signal. Now you observe from this point onwards, my signal is starting, that is at t is equal to -6, my signal is starting. Basically ramp signal starts at t is equal to 0. Then I can write that signal as r of t. But this, at this point, ramp will be starting at -6. So this is advanced signal, and definitely this is advanced signal. So I can write this as r of t plus 6. So this is a ramp like signal going from this 6 point onwards with a slope. Now what is the slope of this line? To find out the slope of this line, you measure this distance, x distance. So this distance is -6 minus 4, that is nothing but 2 units. This unit is, this is delta x, let's say it is 2 units, and let's find this as amplitude as a 10. And you observe this amplitude, that is delta y, this is equal to 10. So this amplitude, this y amplitude is 10. So delta y is equal to 10. So my slope delta y divided by delta x is 10 divided by 2, which is 5. So my line will be something like this. So this is 5r times t plus 6 is the mathematical expression of this ramp, which is starting at -6. Now this ramp will be going with this slope plus 5 and in this upward direction. Now I want to bring down this line to this. So here the slope will be 0. So in order to bring the slope of this line to 0, I need to subtract. I need to subtract by the same slope. So I will be subtracting 5. When I am subtracting by 5, then what happens? The line which is going through this point with a slope of 5 will come down to this position, and it will start going continuously. But it will start at t is equal to 4. So I will put another ramp at this point so that this will be continued. So this is r of t plus 4. Now at this point this line will be continuous, and it is going continuously like this till t is equal to 10. So till t is equal to 10 this line will be continuous. So at t is equal to 10 at t is equal to 10 this straight line will be going continuously. Now at this t is equal to 10 there is one more ramp which is going by a slope, a negative line slope. So here the slope of the line will be 0. Okay, so at t is equal to 10 I will be having another ramp. So this 10 is a delayed. So therefore I will be having another ramp at t is equal to 10, which is a delayed ramp. And now you observe again the slope. The slope of this ramp will be 10, 12 divided 12 minus 10, it is 2 units, and again it is, so it is 5, so it is 5r, and since it is decreasing in nature, so I will be using negative sign. So at point 12 you observe this line will be going in a negative direction like this. Now I want to stop this line and I want to bring it to 0. In order to bring this I need to add one more line of slope 5r, and it is at t is equal to 12, which is a delayed version. So this is the complete description x of t of the given signal x of t. So you observe with the help of unit ramp signal I have described this entire signal. In this way any signal, any random shape signal, if it is given to you, you can describe such types of signals by making use of unit step and unit ramp. Okay, and that's why these signals, that is unit step, unit ramp, and unit impulse signal, they are called as the elementary signals or singularity functions. Thank you very much. If you like this video, subscribe this video. Thank you very much.